Welcome back to the deep dive.
Hey, it's great to be here.
We are looking at a very specific, and I would argue historic window of time today. We're zooming in on the week of February 22nd through the 28th, 2026. Usually when we do these retrospectives, we're talking about a flashy new image generator or a viral chatbot demo. But this week,
This week was different. It was the week the infrastructure finally caught up to the hype.
it was the infrastructure week.
Yeah.
But it came wrapped in a $50 billion headline. That is the number everyone is throwing around regarding the strategic partnership announced between Amazon and OpenAI. And I have to admit, when I first saw the push notification, I was a little confused. I thought OpenAI was legally married to Microsoft and Azure.
That is definitely the common perception. But if you dig into the actual announcement, the $50 billion is almost a distraction. It's a huge number, sure, but the real story is the plumbing. For the first time, we are seeing OpenAI frontier models coming to AWS as the exclusive third-party cloud provider. That is a massive shift in the geopolitical map of AI.
A total realignment.
Exactly. But the detail that actually matters for the builders and the engineers listening isn't the corporate maneuvering. It's a specific phrase buried deep in the technical notes, the stateful runtime environment.
Stateful runtime. It sounds incredibly dry. It sounds like something you'd skip over in a terms of service agreement.
It does sound dry, but it effectively solves the single biggest architectural problem we've had with large language models since day one.
You're talking about the goldfish memory problem.
Yes, the amnesia. Until now, LLMs have been completely stateless. You send a request, the model processes it, fires back an answer, and immediately forgets you exist. If you want it to remember what you said 5 minutes ago or what tool it just used, you, the developer, have to bundle that entire conversation history and send it back with every single new message.
Which just eats up your context windows, it increases latency, and costs an absolute fortune in token fees.
It's inefficient, it's fragile, and it's incredibly messy. This new partnership involves co-developing a stateful runtime on Amazon Bedrock. It means the agent actually lives on the server. It persists. It remembers tool states, variable values, and conversation history natively.
So it's the difference between a chatbot that resets every time you blink and a digital employee that actually has a desk, a filing cabinet, and a memory of what it did this morning.
That's a great way to put it. And that seems to be the theme of this entire stack of research we're looking at today. We are moving from chatbot to agent. We aren't just generating text anymore. We are executing code. We are managing state. And in one case we'll get to later, we're actually letting AI manage 5G network slicing.
The agentic shift. That is the underlying headline for this deep dive. Let's start with the intelligence itself, though. Because while the OpenAI news sucked up a lot of the oxygen, Anthropic didn't exactly take the week off. The week of February 23rd, we saw Claude 4.6 drop on Bedrock. Now, I feel like in the Anthropic family tree, Sonnet is usually the middle child.
The middle child, yes, but really the most important one for actual enterprise work. You have Opus, which is the massive brain. It's slow, expensive, brilliant. You have Haiku, which is fast and cheap. Sonnet 4.6 is fascinating because if you look at the benchmarks, it's effectively cannibalizing the previous generation's Opus.
So you're getting Opus-level genius performance, but at that middle-tier price point.
And the middle-tier speed, that is the critical part here. For a developer, building an agent that needs to run loops, so code, check, debug, code again, latency kills you. You can't wait 30 seconds for an Opus response every time the agent wants to check a variable.
Right, that would be agonizing.
Exactly. Sonnet 4.6 sits in that sweet spot where it's smart enough to write complex code but fast enough to run in a real-time loop. It is positioning itself as the absolute workhorse for production software.
Speaking of production software, there was another update on February 26th regarding reinforcement fine-tuning, or RFT. Now, I want to unpack this with you because fine-tuning is a term that gets thrown around a lot. Usually, people just mean training the model on my specific data.
Right, and that's supervised fine-tuning, or SFT. That's the old way. Think of SFT like using flashcards. You show the model a question and a perfect answer. You do that 10,000 times. The model learns to mimic the style of the answer. It's rote memorization. It's great for tone, but not necessarily for logic.
Okay, so how is RFT reinforcement fine-tuning? How's that different?
RFT is less like flashcards and more like grading homework. You don't necessarily give the model the perfect answer up front. You give it a problem, the model attempts to solve it, and then you provide a reward function, basically a grade.
Let me see if I have this right. So if I'm training a model to write SQL queries, I don't just show it thousands of good SQL scripts.
No, you let it write the SQL. Then you run that SQL against a dummy database. If it works and returns the right data, the model gets a reward. If it crashes or returns the wrong data, it gets a penalty. The model creates its own internal pathways to figure out how to get the reward. It actually learns the logic and the reasoning process rather than just mimicking text strings.
And the big news this week is that Bedrock opened this up for open weight models.
Exactly. Specifically, Qwen and the OpenAI-compatible GPT-OSS. This is a massive democratization moment. Previously, RFT was the secret sauce of the big labs because it's hard to do. It requires complex infrastructure.
It's expensive.
Very. By putting this into a managed service, AWS is saying you don't need a massive team of PhDs. If you can define a grade, a reward function, you can train a 32 billion parameter model to outperform a massive generic model on your specific task.
That feels like it fundamentally changes the economics of this. You don't need the giant expensive model if you have a smart, specialized, small one that you trained yourself.
You absolutely don't. And for things like finance or healthcare where accuracy is everything, a smaller RFT-trained model is often safer than a giant generalist model that might hallucinate because it's trying to be too creative.
Okay, so we have smarter, specialized models. Now let's go back to that plumbing you mentioned earlier, the agentic shift. On February 24th, Bedrock introduced server-side tool execution via the AgentCore Gateway.
This is one of those updates that sounds boring until you try to build something, and then you realize it changes everything about your workflow.
Walk me through the before and after, because the release notes describe the old way as ping pong.
It was terrible. It was ping pong with high latency. Let's say you want an AI to check a stock price. In the old client-side model, the user asks, "What's the price of Amazon?" The AI processes that and sends a text message back to your app saying, "I need to check the price. Please run the get stock price function."
So the AI isn't doing it. It's asking the app to do it.
Right, it's completely helpless. Your app receives that request, runs the code, gets the price, and then sends the result back to the AI. Then the AI reads it and finally answers the user. That's 3 or 4 hops across the network. It's slow, it's prone to breaking if the connection drops, and worst of all, you are exposing your tool definitions to the client side, which can be a serious security risk.
And the new AgentCore Gateway changes this how?
Completely flips it. Now, the execution happens on the server. The user asks the question. Bedrock sees that a tool is needed. It executes the tool securely within the AWS perimeter via the gateway, gets the result, and just delivers the final answer. Single API call.
So the developer doesn't have to write all that glue code to handle the back and forth.
It deletes hundreds of lines of boilerplate code, and it ties back to that stateful runtime we talked about earlier. If the agent is living on the server and the tools are executing on the server, you suddenly have a very autonomous system. It's not just chatting, it's working. It's acting.
There was another developer-focused update that caught my eye on February 27th. Batch inference standardization. This one seems to fix a very specific headache regarding scaling.
Oh, this is the I hate JSON update.
Explain that.
So when you're building an app, you usually test it in real time. You send a prompt, you get an answer. You use the Converse API. It has a specific format for how you structure the messages.
Makes sense. You want to see if it works right away.
Right. But let's say you want to run that same prompt on 10 million documents overnight to save money. That's batch mode. Until last week, batch mode used a completely different input format. You literally had to rewrite your data structures just to run the batch job.
That sounds incredibly frustrating for developers.
It was a massive friction point. You'd get your prompt perfect in testing and then break it trying to format it for production. The update is simple. Bedrock now supports the Converse API format in batch mode. You write the code once, you test it, you flip a switch to batch and run it at scale. It removes all the friction between experimentation and production.
I want to jump to something that feels very enterprise software.
Yeah.
And I mean that in the best way possible. The SDK lifecycle updates.
The metadata fields. I was weirdly excited about this update.
Yes, the software development kits for Java, Go, and JavaScript got new fields on February 27th. Start of lifetime, end of lifetime, and legacy time. Why is it important that an AI model has an expiration date?
Because it signals that the industry is growing up. For the last few years, we've been in this chaotic cycle where models just appear and disappear. If you're a bank building a fraud detection system, you can't build on a foundation of quicksand. You need to know that the model you're using today will still be supported in 2028.
So this allows them to automate that check.
Exactly. It allows companies to programmatically check their dependencies.
Mhm.
Hey, this model enters legacy status in 3 months, trigger the migration ticket. It turns AI from a magical, mysterious black box into standard, boring, manageable software infrastructure. And boring is what you want when you're running a business. You want predictability.
Let's talk about the hardware that is powering all of this predictability, because we skipped over a pretty massive detail in that OpenAI partnership.
The Trainium commitment.
2 gigawatts. OpenAI has committed to consuming roughly 2 gigawatts of compute on AWS Trainium chips.
To put that in perspective, 2 gigawatts is roughly the power consumption of a major city. It is an astronomical amount of power.
But the strategic implication here is about the chips themselves, isn't it? Because OpenAI has been the poster child for NVIDIA GPUs since the beginning.
They have, and that's exactly why this matters. By committing to Trainium specifically, the upcoming Trainium 3 and Trainium 4 OpenAI is validating AWS's custom silicon. They are effectively saying, we believe these chips are capable of training and running the absolute best models in the world.
That breaks the monopoly narrative entirely.
It puts a huge crack in it. If the leading AI lab in the world is comfortable running on non-NVIDIA hardware, that gives permission to every other enterprise to do the same. It's a huge win for the AWS Silicon team.
Now, for those of you listening who aren't training frontier models and don't need gigawatts of power, there was a more practical infrastructure update. Multi-LoRa serving. We talked about fine-tuning earlier. A LoRa is...
Think of a LoRa, a low-rank adaptation, like a costume you put on a base model. You have the base model, which is naked. Stay with me. And you have a LoRa that makes it speak French, and another LoRa that makes it write Python code. These are small files, maybe just a few megabytes. The update on February 25th was a technical breakthrough in how these are served. Instead of needing a separate GPU for the French model and the Python model, you load the base model once on one GPU, and you swap the costumes, the LoRa's, in and out on the fly for every single request.
So it's like a vending machine.
Exactly. The machine is the GPU, the snacks are the LoRa's. You don't need a separate vending machine for Snickers and another one for Skittles. They showed that they could turn 5 underutilized GPUs into one efficiently shared GPU. For a company running 20 different specialized agents, this slashes their cloud bill dramatically.
Efficiency is money, but reliability is reputation. We saw a massive expansion of global cross-region inference, or CRIS, on February 24th, specifically expanding into the Middle East and Southeast Asia.
This connects right back to the reliability theme. CRIS is like an intelligent traffic cop. Let's say you're running a workload in Singapore. Suddenly, a viral event happens and traffic spikes. The Singapore servers get jammed up.
In the old days, your users just get a service unavailable error.
Right. But with CRIS, Bedrock automatically detects that congestion and routes the inference request to another region, maybe Tokyo or Bahrain, via the AWS Global Network. It processes the data and sends it back.
And the user never knows?
The user never knows. It's totally seamless. And the data doesn't settle in that new region. It's just processed there. But there is a detail in the documentation that I think is incredibly valuable for anyone planning capacity. They explicitly mentioned a 5-to-1 token burn down rate.
What does that mean practically?
It means that output tokens, what the AI writes, count 5 times as much against your throughput quota as input tokens.
Oh, what?
Yeah. It's a specific metric that usually gets buried in the docs, but if you are building an app that generates long reports, you are going to burn through your capacity quota 5 times faster than an app that just analyzes text, knowing that math prevents you from having an outage on launch day.
That is a pro tip, if I've ever heard one. I want to pivot to safety now. Because if we are giving these agents server-side execution and memory and access to our data, how do you know they aren't going to go off the rails?
This is where automated reasoning comes in. We've discussed this concept before. It's using formal logic and math to prove a model is compliant, rather than just asking another AI to check its work.
But the update this week on February 23rd was about showing your work.
Right, it's about auditability. Previously, if the guardrail blocked a response, it just said blocked. Now, when the automated reasoning policy flags a violation, it provides a reference to the specific source document.
So it actually points to the rule book.
Exactly. It says, I blocked this response because it violates Section 4.2 of your HR policy regarding vacation time. It links the black box of the AI decision back to the human-readable rulebook. For a compliance officer in banking or healthcare, that is the difference between we can't use this technology and we can.
And speaking of security, we have to talk about the launch of Security Hub extended on February 26th and the partnership with Safran, because the stat they shared was terrifying.
The exploit window.
5 days.
Yeah, they found that attackers are now exploiting vulnerabilities within 5 days of them being published. Sometimes it's minutes if they are using their own AI tools to scan for holes.
So a human security team physically cannot patch fast enough.
They can't. The math just doesn't work anymore. That's why Zafran is using Bedrock agents. The agent analyzes the threat exposure and actually generates the remediation code. It closes the loop between we found a hole and we fixed the hole.
It's AI fighting AI.
It really is the only way to keep up with the tempo of modern cyber warfare.
Let's look at who is actually doing this in the wild, because we have a prime example of this agentic shift from Nokia.
This was a really cool demo. Nokia and AWS showcased a system on February 24th using Bedrock agents to manage 5G network slicing.
For those of you who aren't telco engineers, network slicing is basically carving up the network for different needs.
Yeah.
Like giving emergency services a dedicated fast lane.
Right. Usually that's a static setting, you set it and forget it. But Nokia's system uses an AI agent to monitor the network in real time. It looks at traffic patterns, it looks at the weather, it looks at local events, and it dynamically adjusts those slices.
So if there's a sudden storm or a massive football game ending, the AI reprioritizes bandwidth automatically.
Exactly. And think about the level of trust that requires. This isn't generating a poem or a picture. This is operational AI. It's turning knobs on critical infrastructure. If the AI hallucinates here, people lose cell service. The fact that Nokia is demoing this shows we've crossed a major threshold in reliability.
And on the other end of the trust spectrum, we have the government.
Kiro launching in GovCloud.
Kiro being that AI-powered developer tool.
Right. Launching in GovCloud on February 23rd means the U.S. government and highly regulated contractors can now use agentic coding assistance. Again, it's a signal. These tools are meeting the rigorous security standards required for public sector work. They are no longer just toys.
So let's step back for a second. We've gone from $50 billion deals to specific metadata fields in an SDK. It has been a massive week. When you connect all the dots, the stateful runtime giving memory, the AgentCore giving hands, the automated reasoning giving rules, what is the big picture here?
The big picture is that the toy phase is officially over. We aren't just building chatbots anymore. We are building software infrastructure that happens to think. When you give an AI memory and the ability to execute code on the server, and you wrap it in math-based safety rules, you have a new kind of digital employee.
The agentic shift.
The agentic shift. But honestly, the most exciting part for me is still that SDK update.
The expiration dates.
The expiration dates. It means this technology is becoming predictable. And for businesses, predictable is improved. Boring is good. When AI becomes boring infrastructure, just like electricity or cloud storage, that's when it actually changes the world.
Make AI boring again.
In the best way possible.
I love that. But it does leave us with one final thought to consider. If we are moving into a world where an AI agent manages our 5G bandwidth, and another AI agent is autonomously writing patches for zero-day vulnerabilities, what happens when these autonomous systems start interacting with each other? What happens when two agentic systems from different companies have to negotiate resources or security protocols at millisecond speeds without a human in the loop? It's a fascinating frontier. Keep building, and we'll catch you on the next deep dive.